If you need practice doing simple circuits, here's a problem that we can work out together. And if you can do this, you could do any of the assignment 6 problems. So I have a battery, 12 volts, and I have 6 resistors in this arrangement, numbered R1 through R6. And we want to find the current through, notice the word through, the current through each resistor and the voltage across each resistor. So I'm reminding you the current goes through the resistor and the voltage would be measured with a voltmeter in parallel across it. So if you were measuring the voltage across R1, you would put a lead here, the meter here, and it would read the voltage. If you wanted to measure the current, you would have to open the circuit here and insert the meter in series to measure the current. Anyway, here we're calculating, so we want to calculate all those. So the first step, if you don't know it, is to simplify the circuit to a single resistor and find the total current leaving the battery. So I'm going to let you do that, and then come back and check your answer against mine. Okay, hopefully you can do this part. So you have to, these are in parallel because they have the same voltage, and you have to do this step first. There's nothing else you can simplify until you do this first. So they're in parallel, so we add 1 over 200 ohms plus 1 over 300 ohms, and then we invert that and we get the combination of 4 and 6, which is 120 ohms. Then once that's done, we've reduced it to 5 resistors, which is identical to the last problem in assignment 8. And then you'll have 3 resistors in series. Don't be confused that these look like they're in parallel. No, current leaving this junction will go through that resistor, has to go through both of these, which we've now reduced to 1, has to go through this. So what makes them in series is they have the same current, so they have to be added as series resistors. And so we have the 120 combination, the 100 and the 80, and we get 300 ohms for the combination of those 4 resistors, which I labeled this way. Now, all these 4 are in parallel with R2, 150. So when we combine 2 with the combination of those 4, we get 1 over the 300 that we found here, plus 1 over the 150, R2, and then we invert that, and we get that all those 5 resistors reduce to a single resistor of 100 ohms. And all those resistors combined are in series with R1, and so we simply add the 140 and the 100, and we get 240 ohms for the total resistance. And then I skipped ahead. The next thing is to find the current, but I equals V over R, but label it I total equals V total over R total. So we have 12 volts over 240 ohms, and we get 0.05 amps. In order not to have a decimal, I'm going to change it to milliamps, so we have 50 milliamps. Okay, now I'm going to put this away, make a table, and you should start to calculate all the quantities I1 through I6 and V1 through V6. And we'll leave the power out of there, but the power is just V times I, so if you have V and I, you can always calculate the power of each resistor. Okay, so start that and come back when you get stuck. Here are all the results. You can look at them and decide if you want to hear my explanation. So let me explain how I did it. First of all, we knew that the total current was 50 milliamps, and so all the current leaving the battery has to go through R1 So immediately I wrote 50 milliamps here, and then I can get V1 by multiplying I1 times R1, and when I multiply I1, of course I'm going to do it in amps, 0.05 times 140, I got 7 volts. And knowing that there's 12 volts and there's 7 volts across the first resistor, then across what's remaining there has to be 5 volts. And what's remaining, that 5 volts, is going to be across all this, but it's also across R2. So R2 is in parallel with the rest of it. So right away I can write down 5 volts for R2, and then I can get I2 by simply R2 V2 and divided by the resistance R2, and I get 33.3 repeating milliamps. So that's 2/3 of this. So what's remaining has to be the 16.66 repeating, or 16.7. So you see that 5 amps comes in and it splits. I mean the 50 milliamps, so 33.3 goes this way, 16.66 goes this way, and that 16.66 that goes this way through R3 I can use to find the voltage. Since it's 100 ohms, it gives me 1.6 volts. So if I put a voltmeter here, I would read 1.6 volts. And if I put an ammeter in the circuit right here in series, the current coming out of here would be 16.7 milliamps, and that's what it reads. Now it gets here and it divides, so we have to figure that out. But then whatever it divides into, it has to come back, and that entire 16.666 milliamps has to go through here before it combines with the 33 coming from here, and there's the 50 milliamps that goes back to the battery. Okay, so it all makes sense. And if there's 16.66 milliamps here, I can find the voltage. And so the voltage is 1.33. And so if I have 1.67 and 1.333 here, that adds to 3, and the total voltage across all this has to be 5. So that means there's 2 volts left here. The other way I can get that there's 2 volts across both these, and they're in parallel, so they both have 2 volts, is, remember, this equivalent resistance of the 20 and 30 was 120 ohms. We got that up here. So if I take the current of 16.666 and multiply it as it goes through that combined resistor of 120 ohms, I will also come up with the 2 volts. Okay, so there's 2 volts across these resistors. We can use that to get the current through both of those resistors. So 2 volts across a 200 ohm resistor will give you 10 milliamps, and 2 volts across a 300 ohm resistor will give you the 6.67 milliamps. And you can see those two currents, that's 16.6, which divides here into 10 and 6.6, recombines here into the 16.66, which combines again with the 1.33, the 13.33, and the 16 and 33 and 16 give you the 50 milliamps that goes back to the battery. So everything looks good, and we're done.